Hello everyone, new video today. So the last time we went through what is called um, async await, which is the ES 8 or 9 uh, way of implementing a promise. So await is actually a promise, and we've explored how to actually convert a promise into an async function. Um, we had also we also so we started with this example. And obviously, when we first started, we explored the observer pattern where you connect to the event and then you just subscribe to that event and then you emit. And then on the occurrence of that event, you would execute things accordingly. And then we also explored the async awaits. So async and await. So await comes before a promise. And we've looked into how promises work because they utilize the dot then, and async awaits basically saves you the hierarchy. It's like tree nested dot thens here. And then we also explored how to execute a function when a promise finishes, which is the dot finally, try catch, and then the finally. And however, there's something interesting that we should also look into, which is .js. Okay, let's take on this example where we have, so let's say set timeout. Okay, we want to do, we want to log console.log. And if you take a look here, it is a callback. So we don't have a callback here, it's an empty one. And then we supply in the timer. Now let's go for console.log. Um, First, this takes on after 0 seconds, and then let's do another set timeout. And then we don't have a callback, but we will have console.log executing second, and this runs for 10 seconds, after 10 seconds. And then we may also have, we might have a promise.resolve. Getting a resolved promise. In this case, we want it to be true. You want to resolve, let's say this is called a promise, and then take some data, or yeah, take data, console.log data. So this gets executed all the time. It takes in data, and then we log in that data. Okay, and then we also need to do, let's say, console.log Genesis. All right, let's try to run this. Now, see, what we have here is very simple. Um, yeah, okay, I made a tiny mistake here. Okay, so this one ends like that, and then 0 seconds. This is 10 seconds. Now, if you rerun this again, okay. Now let's take a look at our results. So we have Genesis and we have Promise. So this came out first, followed by this, and then first and second. Okay, the reason for this precedence is what we call Hold on. Okay, so the last time we seen that we have, um, so we had, sorry, so we had what it called, so this is like the JS part, and then we have like the event loop, and then we have the callback stack, that callback. So let's call this the V8 engine. So, and then of course, obviously we have the API, the web API, or libuv or whatever. So when something gets executed, so the event loop adds all callbacks in here, and then they get executed one at a time. In this case, we have set timeout, it comes in here, and then set timeout also comes in here, and then we have a promise. Now, a promise in the newer versions of JS has been added to um, something new, which is called. So this is the callback queue. This is the callback queue, and this is for the promises. So there's a new. So it's like the promises so the promises take in higher precedence than the callback queues, which is what do they call this, the job queue, which is like a new queue that's been added that handles promises. So in the older versions, you'd have the promises come in after the timeouts we had in our code right here. So in the older versions, you would have these execute together, and then this executes first, because these are delegated to the event. So the event loop goes through these. So these are out of the picture. And then this one gets, so this gets printed out right away, which is what we have here. And then because we have set time and set timeout, these being sent to the callback queue, and then the promise is sent to the what we call to the job queue right here. So this is for promises. And this one right here has a higher precedence than this one. So this has a higher priority than this one. So upon execution, so this one, the runtime goes through the code and delegates these to the callback queue, and they'll get added to the callback queue. And then a promise is sent to the job queue, and then this one is printed out right away. Now the event loop prioritizes the event loop checks this one first, and then goes to this one. So they would run this and then run this one again. So if we try to add another promise, so let's do another promise. Let's call this promise 2. And then if we try to run it, the promises will run before the timeouts. You can see here. So like upon resolving these promises, it gets resolved right away. Hence, it gets printed right away. So this is just it may not be a very critical point, but it's very important to consider this scenario where we have the precedence of promises over the callbacks. Okay, now we have a challenge. Okay, so now when it comes to promises, we have 3 conditions that we want to consider. We have race, we have parallel, and then we also have sequential, meaning that if we have multiple promises, we have 3 cases in which we have 3 cases for the promises to finish. So we have it's either race, so whichever promise finishes first, we're done. Then we have parallel, we need all promises to execute at the same time. Sequential, we want a promise to finish before one after the other sequence, one intro sequence. So I'm trying to create my own promise. I'm trying to apply what I've learned, and then okay, so let's create a constant function. In this case, we will name it. Um, so the course it's named Promisify. I'll name it so just so that I would be able to compare if I'm able to do it right. So this one um, takes in should take in time and the promise and the time. Okay, let's go constant function or function promisify takes an item and delay. And within the function, we want to create a promise. Promise should be let's resolve. And then we want to let's resolve. Okay, so let's resolve. So we want to resolve a promise. All right, sorry about that. Okay, let's do set timeouts. Let's set timeout. I want to do. Okay, let's set timeout. Item and the delay. Okay, so now we have a function promisify. So whatever we send it, it will return a promise. So let's go for new promise. Okay, and then now we want to call so this would return a promise. This should return a promise. Okay, so let's go for constant a would equal promisify, and then we will send it a, and the delay 10 seconds. Constant b would equal promisify, 20 seconds. Okay, so we have now it's in. Okay, so if we try to console.log abc, the callback argument must be a received type string. Oh, okay. So our problem is in here. Okay, so my mistakes that here the set timeout as it's so it's supposed to take in a callback. So now this should return a callback, which is a promise. We want to resolve this one, so it should be resolve item like that, and then the delay. However, this promise here, so we want to, after this amount of time, we want to return a promise, right? Yeah. So it should be like this then. Set timeout, promise.resolve, or we should create like a, okay, it should be promise.resolve. In this case, we want to create a new set node to be set timeout let's do promise.resolve. Okay, so in this case we should be returning a promise undefined. Why is it undefined? Okay. We've returned undefined. So promise if I takes in an item and delay. Well, let's try to see what goes in here. Item and delay. Here we go. A10, so this is okay. Now, I think the problem is right here. So this is fine. It should be, we're not returning anything here, so let's do this. Okay. What do we have? Returning the function itself. It's not a promise actually. So we want to return this as a promise. We want this to be the promise itself. So what we want to do is we want to, okay, let's do return promise to resolve. We want to return a promise. What do we want to resolve though? We want to resolve the timeout. So I want to do timeout, set timeout. Oh my God, sets timeout. Set timeout. So set timeout. This goes to delay. Set timeout. We want to do item. Okay. Let's see if this works. So the same, we still got. What did we get? Oh yeah, we got promises. We got promise 1, promise 2, and promise 3. We got a promise. Now, if we try to run all these promises, promise.all, okay, let's do promise, and then here we will run A, B, C. So then, promises. Okay, and then promises and log promises. Let's see how this one works. We've got a problem. Oh yeah, promise that all those should go like this. So places an array. What do we have? Timeout. We've got a timeouts. It's not what we need. It's returning the timeout itself. It's not resolving it. Okay. Okay, what if we do resolve item? See what turns. Resolve is not defined. Yeah, obviously. Promise.resolve. Set timeout. Item delay. Why is it not giving me the right output though? Promise. Okay, what if it resolves like this instead? It would be promise resolve. You wanna do set timeout. All right, let's do set timeout. Takes it on a callback. Resolve item delay like that. So okay. Set timeout. No do set timeout. Resolve the item delay it. See if this works. Nope. Oh, new. Okay, sorry. Undefined. But what's with console.log a clean C? It's undefined. In the return. Yeah, ABC. we got these promises, then we have A, B, and C. If we do this like that, it should print. Now these are all executed together in parallel. But if we do raise, I think wait, I'm not sure what raise takes in. We can do raise instead and see. Let's see. Which one should finish first? B finishes first. Let's do 20. A finishes first. Okay, so we got raise. Okay, so raise finishes on. We got raise. Okay. We can do the async wait function thing. So let's call it sequential. Async function sequential. Okay, let's go for const results equal await. I'm gonna do await, and then let's do for A. Let's see if this works. Yeah, and then we can just do console result. I want to run A on its own, see the result that comes. All right. I think we should do. Okay, let's just go result is. Yeah, we need to call it. So is A. Okay. What about, let's go for C. Yeah. So it waited for A finished first, hence it appeared first before the other one, like in the previous case. We got A here, and then we got, C next because it finishes later. This is quite interesting. Now, what happens if we added brackets in here? It's a promise. What happens if we did this? We should get an error. Yeah, obviously, because it's not a function, it's actually a promise. We've actually returned the promise from here. I've seen some. Yeah, in this case, we can run C, B, A, depending on what sequence we're looking for. So we can do output 1, and then else in output 2 would be await A, and constant output 3 would equal await B. Or so, and then in this case we can do result is output 1, output 2, output 3. CAB. You want to ensure the sequence. Obviously, you can see it takes longer than A and B, it still finishes first. Because we want to ensure the sequence. So in this case, it could be handy because sometimes we want to run functions one after the other. We want to ensure like one result will depend on the other. Okay, all right. Now this might look a little ugly. Now I've seen some in Stack Overflow actually write it differently. So instead of this, I've seen some do it like this. So there would go const promisify, and then it would take in two parameters, item and delay. Okay, and item and delay would yield new promise, of which now, new promise where you would want to resolve it, and a new promise and its resolution is a set timeout, like that, and it would take away a delay and would resolve here. It would resolve the item like so. In this case, it would still be the same, but it may look better. We still get the same results. So we have a different way to actually put this. So a new promise, it would take on a result. So the resolution of the new promise is actually a set timeout. Okay, all right. I think we've also taken a look at here on the very, when we really started, this take in a resolve and a reject, and then you would do the implementation. So this is the same implementation as we're actually doing here. So it takes in a resolution like that. And the reason why we took long because we forgot how this is actually being made. So we need to practice it more so that we memorize how it's actually, how the syntax of it is. So this is the thing, you promise, you take on the resolution, and we resolve for the following, and for the following time as well. So the brackets is here because we want to output what's in it. Okay. Okay. So now we've taken a look at three different cases. We have the race, the parallel sequence. We have here race, and we've also taken a look at all. When we run all, so what we can do here is actually run all, and we can run a race. And sequence, okay. So I'm gonna run these together and see parallel on the race. The result. So this is sequence. Okay, now let's see which one finishes first. A won the race. Obviously, this finished first because it's a race, followed by parallelism, and then followed by the sequence. So the sequence finished first because obviously you would wait for each and every one to finish, right? Okay, so await C. You want to execute C first and then do the rest of them, right? Okay, so now we've explored the three different cases where we have a race, a parallel, sequence. So this comes in handy for when we do the code itself. Now I am going to, okay, hold on. There's something also to consider when using the all, is that if anyone fails, this one returns a failed process. So this doesn't finish. So there's nothing returned other than, an error. And to make sure that we always get a result, we should do all settled. like that. And this still runs the same. But in this case, you can see that parallel returns objects here because it's an array of the result of each, both resolved and we can, sorry, apologies, let's do this. All right, and look what we get. Status fulfilled and then the status is basically if any one of them fails, let's see, an item, okay, resolve. Okay, let's do if item equals B, else equals B. Let's do reject. Oh, sorry, resolve, reject, and then we can do reject B. So reject item. Okay, if item equals B. Now let's see. In this case, error unhandled. Rejection. Oh yeah, because they're actually running race. So let's do this. Do this. And then we can see here like we got rejected. But if we do all, we will get an error like we've done earlier. See, now we get an error. In this case, we have to do a dot catch. Let's go dot catch E. Now in this case, it will run. But so because it will run, yeah. But the best way about is we can do all settled, and then we can get rid of this. It's rejecting B's, but in this case we can go failed. And you'll get to see, now we can do all, and then the catch. Failed. We got failed in here. But if we do all settled, then we can get rid of this. We'll have a different result, like so. Rejected, and the reason failed. Okay. So this is where all settled comes in handy. Um, yeah. All right. So the next step would be, so now if I think I should start um, coding. No, I still have to go through Node.js. Sorry, yeah. Okay. I should think of something that we should do. Like we should try implementing something. It doesn't have to be professionally done. It just has to be, even if it's novice, it's fine. Like it doesn't have to use databases or anything. Just simple. What's about an informative landing page, an informative site or something? You can kind of create a website. So I want to do something like a transportation page. You would want to have someone come in. It's projected with different heavy duty vehicles, machinery, and then a way to reach us, and then things we can actually do. Okay, maybe reaching out to us. Okay, we're talking about before we end this videos, I've consumed lots of theory and it's been a little confusing. But one of the things that we talked about or that I've been reading on is what we call parallelism, and so we have concurrency and parallelism. Okay, so what happens is that when you have a single core, and then you have like a when you have like a single core, like one core, CPU, one core, and then you'd have different threads in it. So it would take on a thread. When it's done, it takes on another thread, and then it takes on another thread, and so on and so forth. But you can't have two processes run on the same, like at the same time. This if you have like if you run Node.js on a single core. If you run Node.js on multiple cores, then you would have like thread one run here and thread two run here at the same time. But this gets confusing rather quickly. This is what really confused me because so there's actually a way to achieve this. So okay, Node.js takes care of with libuv. It takes care of a lot of things in the background. But if you want to achieve your own kind of parallelism along with concurrency running on multiple threads, there is something called child process in Node.js that you can utilize, but it's a little confusing, so I'm going to skip it. I tried to read up on it, but I feel like I need, I don't need that at the moment. Like I don't have like a clear idea of how I need parallelism at the moment, so I'm going to leave this for when I have an idea that actually to learn. But it's a good thing to know. Like you can achieve parallelism and concurrency with Node.js, even though JS is like a single-threaded language. But with libuv, you can achieve a lot of things in the background. But for now, like I am going to put this on the shelf, put it aside, and not revisit it again because I I think it's better that the best way to understand this is by really applying it, like having a really solid case to actually apply this. And yeah, for now, I'm gonna skip this and get back to it later. But it's a good thing to know. It's a good note. It's a good thing to know that this actually exists. Okay, so I think for now, I think we've read up a lot on. So this whole thing is libuv. Yeah, the V8 engine communicates with libuv, for which it achieves like there is the event loop. But anyways, so I think now we should go back to Node.js. We've spent enough time with promises, and I feel like I'm quite comfortable with promises now. Um, Next step would be for us to actually start doing some Node.js stuff, some Node.js code, and getting and trying to do something very practical. And I'm thinking like you can start with a landing page, like a simple page like this. Yeah. All right, I'll stop the video here. And yeah, I just feel like I'm overwhelmed with the theory that I've been reading on concurrency and parallelism, which I feel like it's not something that I should know now, but I can know about. I know they exist, but I can apply it and get around with it later in the future. All right, see you soon.